are recorded, and
Okay, great.
I post them to YouTube and send you a link, and you can review them. It might take 3 or 4 hours after the session to get it processed, because it takes a while to convert it to a WMV file.
Okay.
So what kind of stuff are you currently going over? Are you in trig yet, or are you still in pre-calc?
We are doing logarithmic functions at the moment, so I couldn't tell you if that is trig or pre-calc
That's pre-calc.
Okay, great.
Yeah, and furthermore, it's probably stuff that you can verbalize pretty easily.
Yeah, definitely.
Okay. You have a problem or two that you can not quite know how to solve?
Right now, we're just kind of doing, expanding, so if we get, hold on, let me find something here.
Okay, so let's talk about the 3 most important rules for expanding.
Okay.
What is that equal to?
Log A plus log B.
And what is this equal to?
Or log A minus log B.
And the third biggest one is log of A to the B power. Is that equal to?
Oh, geez. Okay, hold on. Let me tell you. You know what? I have no idea, actually.
It's B times the log of A.
Okay.
And this is actually the most important one for calculus and higher maths.
Okay.
This is basically the one that allows us to take exponential functions and solve them algebraically. Because if we can take an exponential function and convert it to logs, then we can take that exponent, bring it down, put it next to the log function, and solve it algebraically.
Okay.
So, do you have any specific problems that we would need to use these 3 rules on?
You know what? Let me see. So, I guess what we did yesterday in class was stuff like, all right, you know what? Let me start over. So, we did kind of exponents with the same base, which is easy. That's just kind of...
That's rule 3. That's right. And it's important to realize that they're going to want you to go both ways on this. In other words, you need to be able to expand a log function, and you need to be able to compress it.
Okay.
In other words, if I say to you, what is log of x plus log of x plus 1, then you know that that's the log of x squared plus x. Excuse me.
Sure.
Hi. Sorry about that.
That's all right.
One thing I don't have a whole lot of control over is my dog. Okay, so do you have any examples? I can make some up if you don't have any, but it's always better if there are problems that you really are doing or expected to know how to do.
Sure. So I guess what we did yesterday was 2 exponents with no common base. So we had one that was 6 to the x minus third is equal to 4 to the 2x minus 1.
Like that?
Yes, sir.
Okay. We don't have a common base, as you mentioned here.
Sure.
In other words, if this was 8 instead of 6, then we could call it 2 cubed, and we could call this 2 squared, and we could solve it without resorting to logarithms.
Right.
But because it's a different base, the best way to solve this is to take the log of both sides.
Okay.
In other words, when they taught you in algebra that you could do anything to the left side of an equation as long as you did it to the right, they meant anything. And that means taking the logs of both sides, you can differentiate both sides, you can integrate both sides. Any math function you can think of, you can do it to both sides. So
Okay.
it's legal for me to take, and I tend to work in natural log just because it's kind of the log of higher math. Once you get to calculus, it's almost all natural log. You don't work in a whole lot of logs of different bases than natural log.
Mm-hmm.
So once I've taken the natural log of both sides, now use the rule number 3, the rules of exponents, to convert that.
Okay.
So what can I say now? What's the next line?
Oh, man.
In other words, if the log of a to the b power is equal to b times the log of a, let's use that rule to change each side of this equation.
Alright, so you just got x minus 3 to the natural log, or well, times natural log 6
Okay.
equals 2x minus 1 natural log 4.
And of course, these parentheses are very necessary.
Yes.
Okay. So now what we have is an equation, a linear equation, with one variable. We know how to solve that. We can use Algebra 1 techniques to solve that. Notice that that's just a number and that's just a number.
Right.
I mean, we may not know what that number is, but you can always get that out of a calculator or a table, or, you know, that is just a number. So if I wanted to solve this, I would solve it the same way I would if this was just a regular coefficient like 3 or 4. And that is, I would distribute. Okay? So I have natural log of 6 times x minus 3 natural log of 6 equals natural log of 4 times 2x minus natural log of 4.
Okay.
Okay? What's the next algebra step to solve this?
So we can move natural log 4 over, or oh no, that's a lie.
Well, the next step is to take every term that has a variable in it
Okay, and get on one
and
side.
move it to the same side.
Okay.
Okay, so I'm going to have natural log 6. I'm going to put parentheses around that just so there's no confusion. Minus natural log of 4 times 2x. And then I'm going to move this to the other side. So I'm going to have 3 natural log of 6 minus natural log of 4.
Okay.
And again, that's just a number.
Right.
As is that, and as is that. So the next step would be what? If I'm trying to solve this equation for x.
Well, you need to divide out your natural logs, but you need to combine first, don't you?
How about we factor out x?
Okay.
In other words, if I'm trying to solve for x, remember I'm not trying to solve for natural log. Those are numbers. So I'm always trying to solve this thing for x. So if I factor out x, I'm left with that number minus 2 times that number. And all of that's equal to the right side of the equation. Now, that's just the coefficient to x.
Okay.
So if I divide both sides by that, I have my answer.
Okay.
It's not pretty, but it's made up of all numbers. In other words, you have to go into your calculator to figure out what that is, but that does give you a solution.
Okay.
Okay. What else you got?
Okay, this is, I can't remember if we used a calculator for this. Graph to solve. No, that's okay. No, I understand that.
Okay.
Let's do another with no common base. So 4 to the x minus 2x minus 12. I'm sorry, that's 2 to the x. My fault.
It's okay. I was worried because I didn't like. It's easier if they're all in exponential rather than a
definitely.
mixture of exponential and polynomial.
Right. And then minus 12 as well.
Equals
0.
Okay. All right. Let me think about this for a second. Well, let's move the 12 to the other side.
Okay.
And then let's take the natural log of both sides.
Alright.
Let me think about that a moment. This is also 2 squared to the x minus 2 to the x, which would be 2 to the 2x minus 2 to the x equals 12. So I guess where my hesitation is when we take, if we go back to the original step, I don't see where that is going to advance the solution any.
Okay.
But if we go back to this and we try taking the natural log of both sides, the question is what happens inside here? It's very important not to make this mistake. That is not true.
Okay.
Okay? In other words, if you have the natural log of A divided by B, then it would be the natural log of A minus the natural log of B. But that's not what this is. In other words, clearly this is not natural log of A minus natural log of B, because that would have to be the natural log of A divided by B.
Right.
So the question is, how do we handle natural log of A minus B?
Okay.
All right. So it looks like all we're missing is this one here.
Go back. We'll go back and look at this in the original way. I think I have a way to do that.
I've got most of them anyway. Let's see.
Okay. Now, notice that if I said to you, in other words, this is the same base.
Mm-hmm.
Hold on, I'm thinking for a moment. I should be able to factor out the 2, and I'm left with let's see. Now, let me back up a moment. If I have e to the x times c to the x, that's equal, or e to the c, that's equal to e to the x plus c. Okay, well that's not what we have here. I wonder, if I move the 2x to the other side, now if I take the natural log of both sides,
Right there for me. As soon as you receive that other vertical, give the store a call, let them know you received it. And give them another day set up. I'll come out and get it clean for you.
Wonderful. Thank you so much.
Sure, you've got some optional parts over here, these port cleats.
So I'm actually looking at what I have written, or what we took
Okay.
notes on in class yesterday,
yeah, what do you
and
got?
and it was, and this I guess where my confusion came from was because
That's okay.
there's no log in what we did. There's no natural log, there's no regular log, it's just,
Well, I'm having a hard time hearing you, Caleb.
so I guess, yeah, you know what, hold on, we got some action going on in here.
Yeah, I can hear. So what do your notes say as to what's the first step on this?
So it's 4 to the x minus 2 to the x minus 12 equals 0, and then what we have is 2 squared to the x minus 2x, minus 2 to the x, minus 12.
Okay.
And then what ended up happening,
Now I get it. That's a quadratic.
yes,
That's a quadratic in 2.
yes.
Okay, now I figured it out how to do it. Quadratics can be in anything. Most important thing about a quadratic is that this is the square of that.
Okay.
Okay? In other words, if I took 2x, 2 to the x, and squared it, I would get 2 to the 2x.
Okay.
So
Right.
I want to solve this as a quadratic, and I want to use substitution. Let's let u equal to 2.
Okay.
Hold on a moment. Okay, so if I let u equal to 2, then I would have u to the 2x minus u to the x minus 12. I got the wrong thing here. I want to let u equal So how does this factor? This must factor into 2 minus, let's see, we need factors of 12 that subtract to 1. There we go. Factors to that, correct?
Yes, sir.
I think. Let's see, that gives you 2 to the 2x minus 4 times 2 to the x plus 3 times 2 to the x, which gives you a minus 2 to the x in the middle, and then gives you an end term of minus 12. Okay, now we're making progress here. What can we now say?
We can set those to 0.
Okay, so I can say 2 to the x equals 4, or 2 to the x equals minus 3. Is this possible?
No.
No, you can't take a positive number to any exponent and get a negative number. So that's impossible. But this is possible. And in fact, we have a solution, x equals 2.
Right.
Now, that's an easy solution, given 2 to the x equal 4, but I could do that any number of ways. I could take log of both sides. I could represent this as 2 to the squared, but it's not hard to come up with this answer. All right. That was a toughie. I haven't come across an exponential equation that was disguised as a quadratic in a while.
Yeah, that was definitely a hard one yesterday.
There's lots of different kinds of quadratics. In other words, the one that I'm used to seeing that is not overly familiar to people is something like this.
Okay.
And this is very similar to what we just looked at, only in this case we have e as the base, and in your case we had 2.
Sure.
But if I was going to factor this, it would be e minus 2 times, or excuse me, e to the x minus 2 times e to the x plus 1. And then I'd go from there. But what you can have quadratics in stuff other than x. In other words, a typical quadratic would be x squared minus x minus 2. But it can look like that. It can also look like this. I don't know how much, you've had some trig, so this isn't going to be totally foreign to you, but that is a quadratic in sine x.
Okay.
This would be called a quadratic in e to the x. This is a quadratic in x, and this is a quadratic in sine x. And the problem we were just doing was a quadratic in 2 to the x. That's what you can call that right there, is a quadratic in 2 to the x.
Okay. Perfect. Awesome.
Let's see. This first session's only a half-hour session, as I'm sure you know. And let's see. I believe your sister, is that your sister? Ariana. She has one scheduled for 8:15 tonight.
Yes, sir.
Is that her phone number, the 303-945?
I believe so. Yes.
Okay, so that's the one I should call for her later on.
Yes.
Okay. She's taking geometry.
She is taking geometry.
All right, Caleb, I have your email, and when I finish processing this file, which probably won't be till tomorrow morning, I will send you a link to whatever email you signed up under, and it'll allow you to review the file if you like. And it's pretty easy. It's got fast forward, rewind, pause, all of that good stuff on it. So say you only wanted to review that last problem, fast forward to that, review it.
Okay, good.
It sounds like you have been on my website, or your mom has.
Yes.
She scheduled these appointments. So she can go on there and schedule again if you would like.
Yeah, definitely. I think we have some future sessions as well. So I think
that's right.
just,
you do. Yes. Now I remember. Both you and your sister scheduled. Yeah. Okay. Sounds good.
So I think next time we meet, I kind of want to go back a little bit, because that was the kind of the stuff that was really confused me. Kind of what we're learning now. I kind of missed a few days back a couple, 3-4 weeks ago, and that kind of stuff kicked my butt a little bit.
Yeah, no, that's a good idea. You always want to. It's hard to go forward in math if you don't understand something that's required in order to go forward. So, yeah, no, that's fine. Well, I will talk to you next time. Oh, the next time, Caleb?
Yes, sir.
Is all I will do is text you the meeting ID number. I won't call you.
Okay.
And this phone that I called, 720-666, that you can receive texts on that?
Yes, sir.
Okay. You know how to, you'll now have an icon on your desktop for GoToMeeting, and
Yep.
that's how you get to it the next time. You don't have to re-download it. You just have to pull it up, and it'll ask for the meeting ID. And we can go from there.
Okay, great.
All right. Talk to you next time.
All right, thank you so much.
Bye-bye.